Hello, welcome to RCT, Redstone Compacting Chips, Episode 1. And today we're going to be talking about ROMs. ROMs are basically just ways to automate any sequence. Now, I want this thing to close, and well, in most cases it's better actually just to not use a ROM. It's easier and more compact to manually do it. Even in all of these examples you will show later. It's just an example, and here's a big, very huge demonstration of a ROM. We can actually do better than this, and how we can is with items. So as you can see, we have these items in a hopper, and with them we can actually control how long the signal strength increases or decreases, which can help us control signals and stuff, maybe using red coders, or maybe not, as you'll see in certain examples. So, here are 3 types of items. 64 stackables, where 23 of them makes 2 signal strength. 16 stackables, where 6 makes 2 signal strength. And unstackables, where even 1 makes 3 signal strength. With that, let's move on to this. So this is the same thing as that, but with our new ROM. Now, as you can see, there's actually only 1 signal strength. So how exactly do I calculate the signal strength from here? Well, I actually just take an observer output into here. See, this needs to fire twice, and it always detects when you change the signal strength. As for the signal strength changes itself, there are 2 white walls and 1 sword. So 2 64 stackables and 1 unstackable. And if we put redstone blocks to show, so just for showcase examples, let's say this is 1 signal strength and this is 3. So we can put 1 signal strength here and then 3 signal strength. And as you can see, that makes it work. So let's just show it in this scenario. Okay, so now let's talk about ROM optimizations. Now, the best optimization, as I said for this one, is better to just manually do it. But we can also make small optimizations like this one. Optimizations basically mean instead of having the ROM just control 1 piston, maybe you can have a ROM output for, say, a double piston extender. In this case, I optimize it so when this piston retracts, it just does a double piston extender. So, for example, now I'm going to try and make a ROM circuit for this optimization that does both opening and closing. Here's our final product. So if we put a lever here and try this, as you can see that, it does that on the closing, and on the opening it does this. The way this works is we have to do 1, 2, 3 on the closing and 3, 2, 1 on the opening. And how we do that is with 12 snowballs. Now this actually makes 3 signal strength. I'll explain it in a later episode. So basically what this does is 1, 2, and 3, and then on the opening it does 1, 2, and 3, which does the entire thing. Now, there's actually one more type of ROM that we have yet to talk about. You see, so far we've had to use a bit of cleverness to connect the ROMs to our layout. But what if we want something like this? where you can just control individual pistons, or upon optimization, say maybe have an input for a double piston extender, then you'll need to have a circuit that can choose when to fire certain inputs and outputs. And in this case, there's one more machine that can work, a shulker ROM. The idea is if we have a shulker dispenser here, a piston here, and like a red coder or something else that can decode signal strength, then what we can do is we can do something like this, where we have an item in the dropper and we dispense it out, and as you can see, the red coder reads it as signal strength 3 in this example, and then we can get rid of this one, and then we can do this again, and we'll have another one, and when we dispense it, it actually does signal strength 2, and so on, and we can store a whole sequence of numbers. A way you could add some control to this ROM is to place an observer like this, leading to even the first signal strength from the comparator, therefore making it so that every time the signal strength changes, this fires. So if we put a block of redstone here, it only pulses this for a tiny little bit before it gets put into this chest. And again, another way you can add some more control is to take this that leads into our reset piston and put it into the thing that pulses the next shulker box. So as you can see, if we do our normal double pulse to initiate our ROM, then this will finally complete the entire process needed to automate this and then this, just like in our original ROM over there. This could be used theoretically to use all these original inputs like this example does. Another automated circuit that is often considered a ROM is the simple counter circuit. So as you can see, if we even power this dispenser once, almost like the shulker ROM, it'll keep on pulsing this comparator for a specified number of times. In this case, the specified number has to be 64, as I just put a stack in. So just to show you, I'll take the rest of the stuff out. So this time, let's do it with just 7, and we can even count it to show you the proof. So I let everything in the dropper, and now I pulse the dropper just once. 1, 2, 3, 4, 5, 6, and 7, and that's all the pulses. But unlike the shulker box ROM, this does not give independent signal strength, just gives 7 of the same signal strength, which in this case is 1.